Welcome to the SBDS February update. I'm Brian Stockton, along with Wayne Cooten. Wayne and I will highlight all the new tools, information, and vehicle coverage changes for the February 1996 SBDS software update, along with some new screen changes to previous tools. We'll be using a 1996 Explorer 4-liter and a 1995 Continental for demonstrations, along with some pre-recorded graphs. Let's take a look at what you'll find in your February update kit. SBDS cover letter, February SBDS CD-ROM, EVTM PCED CD-ROM for 92 to 94 car truck, EVTM PCED CD-ROM for 95 to 96 car truck, a February 1996 EEC5 calibration update CD-ROM, a primary installation diskette, a backup installation diskette, a February 1996 SBDS CD-ROM installation instructions kit, 5 Service Bay Products newsletters and tech tips, 5 separate technician questionnaires, 5 February 1996 errata sheets, 2 laminated SBDS vehicle coverage charts, along with 5 SBDS vehicle coverage charts, 2 newsletter summary books, 2 February 1996 highlight manuals, February 1996 highlights video, and 1 SBDS consumables flyer. Let's take a look at some changes to the powertrain toolbox. First though, let me highlight a change to the VIN entry screen. Select Powertrain Toolbox and move to the Vehicle Selection screen. If I touch the Past VINs button, notice now the Hold button is behind the Past VINs button. This change was made to reduce the risk of deleting a VIN by accident. On prior releases, if the Past VINs button was accidentally touched twice, a VIN could be unintentionally removed because the Remove button was in the same screen position on the next screen. Since only one touch is needed to make a selection, the second touch activated the Remove function. This change was driven by your feedback to us through the technician questionnaires you send us. We're going to use a 1995 Continental to demonstrate some new functions in DCL display. We'll touch Continue and scroll to the Electronic Engine Control category. Then we'll select DCL display and select Continue. Remember, on the hookup screen, auxiliary adapters such as fuel or trans pressure are displayed in blue. We're not going to use any auxiliary hookups for this test. We'll touch Continue. The new functions that I'll show you are available in table and histogram displays only. Let's select histogram. The PID selection screen has 2 new additions. One is output state control, and the other is a pinpoint button. The new pinpoint button is located in the lower right-hand corner of the screen. If we have a question about a particular PID, say mass airflow, we can touch pinpoint, the scroll box in this DCL pinpoint menu will automatically default to the PID that we highlighted on the selection screen and display a summary of information about the PID and the pinpoint dialog box. We can also scroll through the list to find information about other PIDs. This screen also contains a description button. Touching description displays this menu of information. Let's look at electrical schematics. And here's our MAF sensor. The MAF signal goes to PCM pin 88. If we touch the book icon, we'll return to the previous menu. We can also touch PCM pin usage. This displays a usage chart which includes pin numbers, circuit numbers, and wire colors. If we scroll to pin 88, we'll find the circuit number and wire color for the MAF sensor circuit. Touching back up will take us back to the menu. We can also select diagnostic reference values. These reference values are displayed in the same format as the PCED. We'll scroll to pin 88. And look for the values for key on engine off, hot idle, 30 mile per hour, and 55 mile per hour. This box indicates the units that the signal is being displayed in. The units we see here are volts. Touching menu takes us back to the DCL pinpoint menu. Touching return will put us back to the PID selection screen.
The other new addition to the PID selection screen is Output State Control, or OSC PIDs. This new feature enables you to turn certain PIDs on and off to manipulate their output. These PIDs are displayed in blue. Just as in previous releases of SBDS, the PID selection screen is divided into the following groups: analog inputs, digital inputs, analog outputs, and digital outputs. The lower left box houses all the PIDs that are strategy or internal PCM PIDs. Let's take a look at IAC. This is an output state control PID as indicated by the blue lettering. When selecting an OSC PID, look at the units box at the bottom of the screen. You can monitor most PIDs in a variety of units. To use this feature, make sure the PID you want to control is displayed in blue. For example, IAC, which is idle air control, can be viewed as fault, percentage, and milliamp. The only blue selection is percentage. In order to manipulate the IAC, you have to select the percentage or blue units option. The other unit options are still available for viewing. IAC is an analog signal. Let's look at a digital signal now. How about fuel pump? In order to control the fuel pump, we'll select it in mode and touch continue. Here's our DCL histogram display screen with all the PIDs that we selected. These changes will give you more flexibility and control when you're using DCL or DCL recorder monitor.
Let's take a look at the pendant. Notice you have a black box next to the IAC on the pendant. This is an indicator that this item can be manipulated. Move the pound sign next to the IAC and press the yes button. An equal sign will appear. The yes and no buttons can be used to increase or decrease the IAC percentage. Notice I'm controlling the idle speed with the pendant. To return to normal operation, select the exit button. Remember, these OSC PIDs can be manipulated under various conditions. The IAC can be changed while the vehicle is in park or neutral and at a complete stop. Some other OSC PIDs can be manipulated while driving. The IAC is an analog signal. Let's take a look at a digital signal. Let's say fuel pump. The fuel pump PID represents the fuel pump control. This is an on or off signal. Use the up and down arrows to display the fuel pump PID on the pendant. Select the Yes button and an equal sign will appear next to fuel pump. The Yes or No buttons will toggle the fuel pump off and on. Let's turn the fuel pump off and toggle the pump back on before the vehicle stalls. We now have a new appended option called Button Help. Select Menu, and move the asterisk with the up or down buttons next to the button Help and press the Select button. The pennant will display several screens of navigational information. To proceed to the next screen, use the up and down buttons. To return to the active test screen, press Menu and move the cursor next to the monitor recorder and press the Select button.
Let's go to a road test. OSC PIDs are also available during a road test. After selecting Road Test, SBDS will display a PID selection screen to verify or change any PIDs prior to downloading the PVA. For example, to manually shift the transmission during a road test, make sure gear is selected. Let's take a look at a recording of a 1997 F-150 truck. During this recording, we manually shifted the transmission. In this graph, you can see the TP and VSS remain steady, and shift solenoid 1 and shift solenoid 2 are changing mode. During this road test, the gear PID was selected and manipulated using the OSC with the pendant. The transmission was first shifted first through fourth and back through using the pendant. The gear PID in the top of the screen displays the command to shift the transmission. Transmissions can now be tested for shifting concerns with the EPC, electrical pressure control, operational using SBDS. As you can see, output state control is a very powerful tool in the bay or on a road test. On some vehicles, auto capture is available during a road test. Be careful not to select this option if you're going to be manipulating OSC PIDs. You can store codes during OSC commands and activate the auto trigger feature.
Another addition to DCL display is OTM, Output Test Mode Status. This is an OSC feature and can be turned on and off in the bay. This is very similar to initializing an output state test on an EEC4 vehicle. Let's select a few PIDs that are turned on during the output cycling test and watch them change on and off in table display. I'm going to use the pendant to turn the OTM on. Notice the PIDs on the SBDS screen. You can see the PIDs change during the OTM command. We still have output cycling tests in the electronic engine control category. This SBDS screen displays the status of the fuel pump and the outputs. We can toggle the outputs on and off by selecting Toggle. To turn the outputs off, we'll select toggle.
Another change for the powertrain toolbox for February is the fuel pressure and fuel leak down tests have been combined. SBDS begins the test by measuring fuel pressure. Next, SBDS displays a timer on the left side of the screen and fuel pressure drop on the right side. The fuel pump is turned off and the leak down clock begins to count down. During the standard 60-second leak down test, the PSI drop is displayed on the right-hand side of the display box. After 60 seconds, the result of the pressure drop are displayed below the specifications. If you need to check leak down for more than 60 seconds, the timer will stay active to let you measure leak down over an extended period of time. The timers will stay active until you exit the test. SBDS will update the log every hour and record pressure and pressure drop. Engine running test, pinpoint test, or injector flow tests are all available anytime during the leak down test.
We have an enhancement in the idle data display test. An idle data auto capture button now can be found on the lower left-hand side of the screen. If any of the PIDs display an out-of-range value, the auto capture feature will record up to the last 10 seconds of data. For example, I'm going to increase the RPM and cause the RPM, TP, and IAC to exceed idle values. This will trigger the auto capture feature. After the capture has been stored, a histogram playback screen will be displayed. From this screen, we can view playback in a graph. While we're talking about graphs, the ignition road test coverage has been expanded to include EI low data rate, DIS, and DI TFI ignition systems. This is similar to the EDIS ignition road test. 6 16-second recordings can be saved during a road test. After the road test data is uploaded to SBDS, it can be played back in spark duration, system test, or a graph. Let's take a look at a graph of a 5-liter GT Mustang which uses a TFI module. Digital signals are displayed at the top of the screen, while analogs are displayed on the bottom of the screen. Let's zoom in to get a closer look at PIP, coil command, and spout.
The BCE toolbox has some new additions for the February 96 update. ABS bleed tool is now available. You can find this under the brakes anti-lock category in the BCE or the powertrain toolboxes. After entering the ABS brake bleed procedure, SBDS will display an information screen with continue and description buttons available at the bottom of the screen. The information in the scroll box has specific routines based on active VIN number. Let's select description. The description button has information such as a schematic, a list of inputs and outputs, a functional description, and information about procedures for manual and pressure bleeding. In order to return to the procedure screen, touch Backup. Selecting Continue will begin the information procedure. This screen instructs us to make sure key is on, vehicle's in park, and the battery is fully charged. The top of the screen informs us to refer to the pendant on the PVA after touching Continue. The pendant displays step-by-step instructions and beeps to remind us that it is active. Press and hold the brake pedal and touch Continue on the pendant. The brake pedal will drop to the floor during this test procedure. The pendant then instructs us to release the brake pedal and touch Continue. This procedure is repeated a second time, after which the pendant will display that the hydraulic control unit has been bled. This SBDS screen also states that the ABS hydraulic control unit bleeding is complete. The scroll box information reminds us to repeat the conventional bleed procedure a second time to remove any air in the system lines. Description is still available for reference information. The final step in this procedure is to perform an anti-lock brake self-test. This brings us to another enhancement on SBDS for the February '96 update. This screen prompts us to prepare the vehicle for self-test. Selecting Continue would start the test, or selecting a new button called More will display additional information regarding self-test and possible responses. Touching Continue will initialize the self-test. Test results are shown in the scroll box, and additional information is displayed in the dialog box. We can also use SBDS to perform a self-test on the ABS systems of the Econoline, Ford Contour, and Mercury Mystique. Since the systems on these vehicles have unique ABS data link connectors, it will be necessary to use Rotunda 007 00580 NGS adapter cable as shown on the hookup screen. This adapter cable should already be in your dealership tool inventory.
Another new change to SBDS is in the communication network test. This test can be found in the powertrain or BCE toolboxes. We'll select Communication Network Test and touch Continue. SBDS will prompt us to hook up the vehicle. After making the connections to the vehicle, touch Continue. SBDS will first search for a standard corporate protocol or an EEC5 network connection. If one is present, SBDS will display the PCM's engineering part number. If we touch Continue again, SBDS will then link with the SCP network to verify its ability to communicate with the modules on the vehicle. If a module fails to respond, SBDS will enter a communication diagnosis routine. In this case, SBDS identified a concern with the cellular phone module. The dialog box instructs us under Causes that the CPM is optional equipment and to verify that the vehicle is equipped with a cellular phone. In this case, there is no cellular phone system installed, so we'll touch Menu. Which brings us to this screen. If your vehicle has an ISO network and you want to test it, touch Yes, which verifies the ISO link. No will return us to the Communication Network menu. The neutral tow feature for the 1996 Explorer is available from the body chassis electrical toolbox under the driveline electronic four-wheel drive category scroll box. You will need to install an NTF kit prior to enabling the function. Let's touch Continue. This screen allows us to enter the build date and the transmission type for this vehicle. Remember, automatic Explorers built before 1295 cannot be programmed with NTF. This is a typical BCE hookup screen. This screen includes warnings, information, and instructions pertaining to NTF. Remember, this feature is only available on 4-liter Explorers built on or after 1295. The instructions tell us to make sure the battery is sufficiently charged to start the engine, the LED is installed as outlined in the NTF enabling kit instructions, and the key is on and the engine is off, and the transmission selector is in park. This screen displays the current GEM module setting for NTF. The description button will give us a schematic, input outputs, and functional description information. Selecting the Enable button will reprogram the module for NTF. Let's touch Enable. SBDS will execute the neutral tow feature command. After the command has been sent, SBDS will display the updated NTF setting. The NTF feature is now enabled for this vehicle. You can also disable if you'd like. Let's touch Continue to finish NTF. After enabling this feature, we need to make sure that it works properly. This screen provides step-by-step instructions to activate NTF. Touching Continue will display the NTF decals found in the kit. This is the last screen for NTF. Just like in the NTF enabling kit, SBDS reminds you to affix the decals in the correct locations on the vehicle. Continue will take us back to the main tool menu. This GEM module has now been programmed to perform NTF at the customer's request. If you're not sure of the procedure to activate the NTF function, select System Description. We also have a couple new additions to vehicle coverage for the February 96 SBDS update. The new 1997 F-150 and the 2-liter probe will be added to the powertrain and BCE toolboxes. Well, that's it for the changes to powertrain and BCE toolboxes for the February 96 update.
Along with the new enhancements and tools, the SBDS information module has also been updated. Look for the following 1996 EVTMs: Probe, Mustang, Ranger, Motorhome, Bronco, F-Series, F&B Series, Mark 8, Windstar, Ford Thunderbird, Mercury Cougar, Ford Taurus, and Mercury Sable. Remember, the information module is updated monthly, including new TSBs, recalls, EVTMs, PCEDs, transmission charts, and emission calibration information.
Take some time to try out the new changes to BCE and powertrain toolboxes in the February 96 update. And remember, if you have any concerns with SBDS, contact the Ford Technical Service Hotline. As always, keep sending us your comments to the Service Bay Products newsletter questionnaire regarding SBDS, SBTS, SBIS, and NGS. Keep up the good work and watch for the next video update.